When adding polynomials, we are doing what is called combining like terms. As you recall, like terms have the same base and exponent. So when we look at this trinomial plus a 4-term polynomial, we're looking for terms that have the same base, the same variable, with the same exponent, the same power. And I look and I see that I have x to the third and negative 4x to the third. These have the base of x and the exponent of 3, so they are like terms. When I combine those, I have 1x to the third. I can remember that this is an invisible 1, and minus 4x to the third, which I could write as 1 minus 4, both being multiplied by x to the third. I just factored out my common factor. And 1 minus 4 is, of course, negative 3. Bring down x to the third. I look for more like terms, and I find that negative 5x squared shares a like term with positive 2x squared. I have the same base of x and the same exponent of 2. So I have minus 5x squared plus 2x squared. Well, this is negative 5 plus 2, both multiplied by x squared. Negative 5 plus 2 is negative 3, and bring down my x squared. I continue to move across, and I find that I have 6 and negative 8. Now, these are both integers, these are both just numbers, so I can go ahead and combine those up. So I have positive 6 minus 8, which gives me negative 2, which I'm going to bring down as well here, minus 2. And then finally I have 3x to the fifth, which doesn't have any like terms, so it just stays as positive 3x to the fifth. Now before I write my final answer, I'm going to go ahead and write the order of my terms from highest to lowest degree. And by degree, I mean the exponent of the term. So x to the fifth has the highest exponent. 5 is the largest exponent here. So I'm going to write 3x to the fifth. The next highest exponent is 3. So I'm going to now write subtract 3x to the third. My next highest exponent is squared. So I subtract 3x squared. And then I'm left with minus 2. And there's my final answer.